OpenAI has just come up with Swarm, and they've clearly mentioned that it's an experimental and educational framework. They have said that it's lightweight multi-agent orchestration framework, but they have also mentioned that it's experimental and it's not intended to be used in production and therefore has no official support. That means you cannot send any PRs, they won't be reviewing any PRs, and they won't be merging any PRs or issues. So why have they even come up with this framework? The primary goal of Swarm is to showcase the handoff and routines pattern explored in the Orchestrating Agents Handoff and Routines cookbook. So they have written a cookbook where they have clearly said that they are introducing the notion of routines and handoffs, and they've clearly walked through the implementation and shown how that they can be used to orchestrate multiple agents in simple, powerful, and controllable way. And the sample repository they have created is Swarm. So I believe Swarm is not going to be a kind of a production level framework that can be used by many others, at least at this stage. It is just to demonstrate the idea of routines, and it's up to us how we make use of the routines. So if we understand routines, then that idea is more powerful compared to sort of getting ourselves very comfortable with Swarm. So let's dive into routines. So the notion of routine is not strictly defined and instead meant to capture the idea of set of steps. So what exactly is a routine? They are saying that a routine is just a list of instructions in natural language, and it is provided with the system prompt. For example, let's have a look at this system prompt that they are provided. You are a custom support agent. You always answer in a sentence or less and follow the following routine with the user. So they have given something called the routine, and now you can list the steps that the agent has to follow or the model has to follow. Let's understand this system message in a simple scenario where the model is interacting with the user. The model is first asking questions and understanding the user's problem deeply. With that understanding, it needs to propose a fix, and if the user is really not satisfied, then it needs to offer a refund, and if accepted, it needs to search for the ID and then execute refund. In order to execute this, we can say that it needs two functions. One is to search for the ID from the database, and then it needs to execute the refund, probably by invoking a payment method or interacting with some other bank through another API. So we need to write two functions. One is to look up items in the database, which is to find the item ID, and next one is to execute refund, where the item ID is passed and the reason is passed, and probably it updates the database with the reason and the item ID. So these two are the kind of tools in order to execute the routine. So to understand how we typically handle user queries in a chat app, we need to invoke the chat.completions.create, and we get the response and we get the message from that, and then we need to return the message, and we do this in a loop so that the user interacts with whatever the query that they have, and obviously we get the message, we append it to it, and then we pass it to the system. This is very basic stuff as to how we kind of develop a chat app using the OpenAI chat.completions.create. Now this currently ignores the functions calls, as in we don't have the two functions that we just wrote, which is to look up the item and execute the refund. So what we need to do is convert these functions into JSON schemas, because the OpenAI prompt only takes functions as JSON schemas. So we need to write a kind of meta function which converts the Python function to JSON schema. We don't have to dive deeper into this function, but as an example, if this is a sample function, it converts everything into a JSON, and we can see that the function name is there, the description is there, and the different parameters are there. Parameter 1, 2, the third one, and some options. Similarly, we have in the JSON param 1, param 2, the third one, and some options. So once we do that, we modify the chat.completions and provide the tool schema that we created as a tools parameter whenever we create the chat.completions.create. The model is now equipped with these tools, which are execute refund and lookup item. So that's how we can pass the tools that we create. How I understand the tools is that they are kind of functions which are interacting with external system in order to serve the model. So execute refund is a tool and lookup item is a tool, and those tools converted to schemas are then passed as parameter. But practically speaking, the agent might have to invoke these tool calls more than once. For example, if the user had query about two products, let's say, and the two products have to be dealt with separately, the agent will get all the details, first look up the first item, and then probably execute a refund. For the second item, it will look up the item again and may not execute the refund, but it has to go through this loop at least twice. So in order to handle a situation like this, they are proposing to put it in a loop. So we loop through the chat.completions.create. We get the response for each of the messages. Once we get the response, we check whether there are any more tool calls left, and if there are no more tool calls, then we'll break out of this loop. Otherwise, we execute each of the tool calls, one after the other till we are exhausted. And once the tool call invocation is complete, then we finally return the message. This is just a small function in order to handle the tool call. Because the tool call is a function, we need to get the name of the function, we need to get the arguments that needs to be passed to the function, and we just invoke it basically. So this way of handling of the tools in a routine is fine, but what happens if there are many more tools to be handled by the same routine? Then it becomes too complicated, and this is where they are introducing the notion of agents. If we group the tools into separate specialist functions in order to execute a specialist role, then it's an agent. For example, let's take the sales agent. It is equipped to look up for item in the database, and so it's a sales agent. Similarly, this agent is a refund agent, and it's able to handle any refunds that the user wants. Probably it is equipped with other tools that are related to dealing with any refunds. And so handoff is an agent handing off the conversation to another agent, similar to how you transfer to someone else who's a specialist in a particular question or in a particular domain whenever you're dealing with a user query. So they have defined agents now. So you can define a class as agent, and it's got a name, it's got a model that's specific for that agent, and it's got specific instructions how it needs to behave, and it's equipped with different tools that are going to help the model to execute its duties. And so our code for the run full turn now has the agent.model as the model instead of just the model. Because we are now dealing with agents, we can literally define multiple agents. Like we saw, we can have a refund agent, and we can create the agent by providing a name, instruction, and the tools. And we can also have a sales agent, which can get the instructions and also the tools, which is the place order function. And whenever the user asks any question, we can invoke the run full turn, and we can execute this loop, and we will be using the agent's model instead of just using the model. And the agent is equipped with all the tools that are necessary to execute its duties. Great. But the handoff is manual here, and we want the agents to decide when to perform the handoff. So for that, we need to use handoff functions. One of the clean ways to automate it is to make the handoff happen by asking it to transfer to XXX, where XXX could be some agent. Whenever the tool is executed, for example, the execute refund or place order is executed, they normally return a string. Instead of returning a string, what if we return an agent object? Then now all that happens is that whatever the agent is returned, that agent will be invoked, or rather the control will be handed over to that agent, and the agent will take over from there. So that's what they are saying here. We have the refund agent, and then we have transfer to refund, and whenever transfer to refund is invoked, the refund agent will be returned, and the refund agent is actual agent instead of being a string. If we update the code now to run the full turn, we will start with the current agent, and from that agent we will get a response and go through these loop in order to exhaust the tool calls. Once we have handled all the tool calls, we will be handing over to the agent. So they are wrapping it up by giving a nice example. Transfer to sales agent returns sales agent. Transfer to issues and repairs returns the issues and repairs agent. And transfer back to triage. Triage is an agent, and we can create the triage agent by providing them the different tools, the different instructions, and the name triage agent. And the instructions are: you are a customer service bot, introduce yourself, always be very brief, gather information to direct the customer to the right department, but make your questions subtle and natural. And then there are these execute order routines. And then there's the sales agent, which has got its clear instructions and the tools to work with. And then there are these routines, which will be used by the issues and repair agent. For example, the execute refund is passed as a tool here, and lookup items is passed as a tool to the issues and repairs agent, and transfer back to triage is also passed. And whenever the transfer back to triage is invoked, obviously it's going to transfer back to triage is going to return the triage agent, and the control is going to be passed back to the triage agent. You can see that the transfer back to triage is returning the triage agent, which is an agent object. And so in order to run this in the loop, we start with the triage agent and we pass that agent to run the full turn. So it's going to run the full turn with this agent, and this agent is going to pass the control to different agents in different stages, and finally is going to get the response, and the response is going to be appended to the messages. And once the response is exhausted, it's going to be passed back to the user. That's a nice and neat example to understand both the routines and handoffs, and they've clearly mentioned that it's a proof of concept, and they've packaged these ideas into a sample library called Swarm. So Swarm is pretty much the library that demonstrates what is possible, how we can build these agents and make them sort of interact with each other using different handoffs. It is meant as an example only and should not be directly used in production. So they've made it very explicit that it's not production ready. So that pretty much wraps up our explanation of the OpenAI's Swarm and the ideas behind the Swarm, which is pretty much the agents, the routines, and the handoffs. So if we are clear with these three concepts, then I don't see any problem with sort of implementing complicated design with multiple agents interacting with each other. So with that, I'm signing off, and I hope this was useful, and I will see you in my next video. Until then, take care.